Hello there, welcome to this lesson. We focus on functions and inverse functions. It is based on question 6 in the paper that we're doing for exam preparation series. And I believe so far we have watched all the videos that pertains to this series, question 1 all the way to 5. You're up to date. If not, I encourage you to do so after watching this one. Okay, so what is the question that we'll be interacting with here? Let's take a look. Good. So what do we have here? We have the graph, yes, and sketched is the graph of f and the graph of g, the point of intersection is happening at B, and you are given the x-intercept A of G, the coordinates are not given though, and this also has a corresponding y coordinate of 1. Equations are given. F is a root function. You know that it comes from a parabola with a restricted domain in this case, as we can see, and this is a logarithmic function, and it has unknown variable a, and the root function has unknown variable k, and obviously we can expect that we'll be asked to solve for those two. Okay, question A, we are asked to find where this is happening. Where are we going to find f of x being greater than g of x? And if we follow the graphs, f starts at the origin and g is somewhere below the x-axis, and we follow them. F is above all the way to the point of intersection, then it will be below g. Okay, so we can clearly see that from 0 to 3 in this region here, f is definitely above. So between 0 and 3, the x values that are there satisfies this inequality. Okay, so this takes care of question A. Let us take a look at question B. Good, so as we said, we will be asked to find the values of A and K. Okay, so let us do so. Point B is a point of intersection, so it's a point that we can use for both F and G by substitution. Okay, so how? For F, we're going to put the 1 equal to square root of K times 3. We need to solve for K, so we need to square both sides. We have 1 equal to 3K, and therefore K is equal to 1 over 3. Okay, for G, we have 1 equal to log base A of 3. Okay, log to an exponential form, the base maintains its purpose. It's A to the power of 1 is equal to 3. So therefore, A is equal to 3. So it's a base in log, it's a base in exponential form. Okay, so that takes care then of the solutions for question B. Straightforward. Let us go to question C. Alright, so we are now asked to find the inverse of f and state its domain. Okay, and obviously there's a certain format we need to use, y equal to something. Okay, so we just replace this with y equal to square root of x over 3. How do you find the inverse? X becomes the y becomes the x. They interchange, so we interchange them here. X equal to the square root of y over 3, and we need to solve for y. Okay, how? Square both sides, and then we have x squared equal to y over 3, and therefore y is equal to 3x squared. Okay, we can see that the domain for f is x equal to or greater than 0. Okay, so the inverse of f is a parabola, okay, but it needs to adhere to this. So x must be greater or equal to 0. So if we had to sketch it, something like this would result. Okay, such that when you find the inverse along the symmetry line. Look at the beauty here. Okay, this F inverse will be mapped to F mapped to F inverse. All right, so the domain then is x greater or equal to 0. Okay, guys, this takes care of the first question under section B, the higher order section, but clearly you can still collect as many marks as possible here, and I encourage you to continue in the paper and do the rest and wait for the upcoming video, question 7 and 8, and so on and so forth. So thank you for tuning in. See you next time. Sharp, sharp.